Hello and welcome to the NIE Sustainability Learning Lab video series on water quality. Today, with Grace we will examine the environmental importance of pH and also how to measure pH. pH is one of the most commonly measured environmental parameters that we see, and that's mainly because it's very important as far as water chemistry goes, but it also has an impact on aquatic organisms. In addition, it's relatively easy to measure and it can be measured fairly inexpensively.
Prof, most people are familiar with the term pH, but what does it actually mean?
That's a good question, Grace. There's a little bit of a debate about that. Some people have suggested that pH stands for potential hydrogen. Others have said it means the power of hydrogen. Regardless of which definition you use, you're really measuring the relative concentration of H+ ions to OH- ions. The pH scale itself goes from 0 to 14, with 7 being neutral, less than 7 being acidic, which means you have a higher concentration relatively of H+ ions, and greater than 7 is basic, which means you have relatively a higher concentration of OH- ions. It's also important to remember that the pH scale is logarithmic or nonlinear. And what that really means is that if we go from a pH, say, of 6 to 5, we've actually increased the acidity by 10 times, or by a factor of 10. If we go from 6 to 4, we've increased the acidity by a factor of 100 times. Some people are also surprised to find out that the pH of rainfall, for example, in a pristine natural area, unaffected by human activity, actually is naturally acidic. It's a pH of around 5.6. And that's because of the gases that dissolve in the rainwater. So we have carbon dioxide, nitrous oxides, sulfur oxides that dissolve naturally in the water. It's part of the natural composition of our air, and that makes the rainfall somewhat acidic. So Grace, let's demonstrate how gases dissolving in water can affect the pH. What we're going to use is lime water here, and we're going to start by measuring the pH. And the pH of the lime water is somewhere around 7, possibly a little bit more, maybe about 8. Now what I'm going to do is introduce carbon dioxide into the water by respiring. And this basically is what aquatic organisms do also in water bodies. Now that I've introduced carbon dioxide into the water through respiration, let's remeasure the pH. We now see that the pH has become considerably more acidic. We're somewhere around 6 to 6.5 pH.
So Prof, does the pH of a water body always remain the same, and what factors affect it?
That's a very complicated question, Grace, but one well worth considering. In fact, a number of factors can affect pH, and the pH can vary from day to day, throughout the day, or by season, or even by watershed. For example, at nighttime, when green plants and algae respire, they introduce carbon dioxide into the water, just like we saw in the demonstration. So at nighttime then, the pH in a water body may drop, it may become more acidic. In the daytime, when those same organisms, the plants and algae, are photosynthesizing, they're introducing dissolved oxygen into the water again, and that becomes more important. And as a result, the pH will increase or go up, become more basic. And so we might see a daily cycle then of pH, very much like we saw the daily cycle with dissolved oxygen. Other factors that can affect pH include rainfall and human activities. So as humans combust fossil fuels or burn fossil fuels, they introduce sulfur oxides, nitrogen oxides into the atmosphere, and that will increase the acidity of the rainfall, which will eventually increase the acidity of rivers and streams and ponds. The characteristics of the watershed also will affect the pH. So for example, if we've got a watershed that has a limestone bedrock, The limestone will buffer the water and the pH will be quite a bit higher. On the other hand, in watersheds in some areas in Malaysia and Indonesia, they have peat swamp forests, and the rivers draining those peat swamp forests are very acidic. They might be around a pH of 2.6 to about 3.6, and that's because of the presence of a lot of organic acids and humic acids. There are other factors as well that affect the pH of an area, particularly if you're in an area where they're mining and they're either mining coal or iron ore that introduces acidity into the water through the runoff going through the mine tailings and mining activities. So a number of factors then can affect pH. In general, the pH is very important in water chemistry, for example, because if we have an acidic pH in a water body, that will tend to release the metals that are attached to sediments that are sitting on the bottom. It makes the metals more bioavailable, potentially more toxic to aquatic organisms. The pH also affects organismal activity as well. For example, the salt balance in tissues can be affected by the pH, and that may affect the reproduction capabilities of that particular organism. Of course, different aquatic organisms will have different tolerance ranges for pH. As we see in this graph, for example, snails and clams are less successful in acidic water than frogs and perch. So Grace, could you show us how to measure pH, please?
Sure, Prof. Most of you will be familiar with the water quality test kits provided by the PUB. One of the parameters it measures is pH. After you collect your water sample, fill the test tube up to the 10 milliliter mark. We then drop 1 pH tablet into the test tube, cap it, and mix the tablet well by inverting it or gently shaking it. Allow the colour to fully develop. We can then compare the colour of the sample to the pH colour chart. It is okay to estimate the values if the colour of the sample falls in between the colour chart values. In this case, we can say that the pH of this sample is about 7. Some schools have access to an electronic pH meter. We will discuss measuring pH using a YSI meter in another video.